So what is the unit circle? What are degrees? What are radians? How do we convert degrees to radians and vice versa? And how do we find coordinates? Well, in this video, you will learn what the unit circle is and its purpose, what the values on the unit circle mean, how to convert degrees to radians and vice versa, how to find coordinates. To start, this is the unit circle, and it is used as a tool to solve for angular sines, cosines, and tangents. This may seem daunting at first, but all we need to know is that the unit circle has three types of values. We have degrees, radians, and coordinates. All three rotate around the circle. In the unit circle, we have both degrees and radians, which both act as measurements for angles. To convert degrees to radians, we will use this formula. Degrees times pi over 180 degrees equals to radians. Let's convert the degree of 120 into radian. Using the formula, we will multiply 120 degrees with pi over 180 degrees. Let's cancel out this degree symbol and multiply. We will then simplify our answer. The answer is 2 pi over 3. We could confirm our answer using the unit circle, and looking at it, it is 2 pi over 3, which is the same as our answer. Now to convert radians to degrees, we will use this formula. Radians times 180 degrees over pi equals degrees. Let's now convert our answer back to degrees using this formula. We will multiply 2 pi over 3 with 180 over pi. Let's cancel out the pi symbol and multiply. We will then divide 360 with 3. The answer is equal to 120 degrees, which is the same as what we had converted earlier. To find the coordinate, let's remember that in the unit circle, cosine is x and sine is y. So to find the coordinates x and y, we need to find both cosine and sine. Let's use the angle 120. However, if we were given a radian, then we would need to convert it into degrees first so that we could find the coordinates. Since we already have an angle, the next step is to make a grid and plot the 120 degrees. Let's start here at 0 and move counterclockwise. This is 0, this is 90 degrees, and this is 120 degrees. We will now draw either a 30-60-90 triangle or a 45-45-90 triangle. Since 120 degrees is 30 more than 90, then we will use the 30-60-90 triangle. If it was 45 more, then we would have used the latter. We have a reference angle of 60. Since we are in the second quadrant, that means that cosine, which is x, is negative, while y, which is sine, is positive. Let's get the cosine. Cosine is equal to adjacent over hypotenuse. The adjacent of our reference angle of 60 is 1, and the hypotenuse is 2. Let's now get the sine. Sine is equal to opposite over hypotenuse. The opposite of our reference angle is square root of 3, and the hypotenuse is 2. The coordinates x and y are -1 over 2 and square root of 3 over 2. If we look at the unit circle, it should be the same as our answer. That's pretty much it.